That's the theorem. Think back to what we were looking at before. We drew a triangle that was 3 and then 4. And to our surprise, we found that there was a 5 up here. Have a look at this theorem. Let's crunch the numbers, okay? Here's A and B, right? So you do A squared plus B squared. That would be 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16, which is 25, which of course is 5 squared. Okay, I can go again. What was the next triangle we drew? I believe it was a 5, and then a 12, and then a 13. It's true. 25 plus 144 is 169. Okay, you can go again. The largest triangle we drew was 8, 15, 17. 64 plus 225 is 289. It works for every triangle, even the really funky ones. I'm going to leave that up there as a question mark for a second. I promised I would leave this all up on the board. I assume most people haven't finished writing everything down. So I'll give you a couple of minutes to catch up. If you have written everything, then I wonder if you can work out what that question mark is actually without measuring. You have a look at it. You have a look. Let everyone else have a go. We had a look at this. Here are some examples of it. Now here, we were like 4.1, 4.2, who knows? Okay, well we can actually work it out. We can work it out using Pythagoras' theorem. Excuse me. So here's what we're going to do. I'm going to call this H. Anyone want to suggest why H? It's not just because I don't like hypotenuse, thank you very much. It's not just because I don't like A, B, C, D, and so on, until G. Ooh, H, I finally like it. H for hypotenuse, okay? Now that I've given it a name, I can work with Pythagoras' theorem here, okay? So go back to where you drew this triangle right at the top, if you've got some space here, right? We're going to write this sentence, Pythagoras' theorem, for this triangle, okay? It should be 3 squared plus 3 squared, they're the shorter sides, should be equal to h squared. Very good. Now, where does that come from? Where it comes from is Pythagoras' theorem. That's the reason why this is true. So I'm actually going to write over here, I've run out of space, so I'm just going to squeeze it in. Pythagoras' theorem. Okay? That's the reason. And you should write it as well. Okay, this doesn't just come out of thin air. Just like this doesn't come out of thin air. It comes from reasons. Well, this comes from a reason as well. Okay, so I'm going to put there Pythagoras' theorem. Now I can work out the answer, right? We know what 3 squared is. It's a small number. It's 9. So I've got 9 plus 9. 9 plus 9, of course, is 18. So now I have h squared equals 18. Okay. So now if I want to know what h itself is equal to, not h squared, right? That's why we spent all this time, I rubbed it off, looking at surds and square roots. H will be the square root of 18. Now I know it's between 4 and 5 because the square of 16, the square root of 16 is 4, and the square root of 25 is 25, right? 5. So get your calculator out. What's it actually equal to? Morgan.
4.24264068711928.
Okay. Excellent. So now you can see why some people measured 4.2. Some people measured 4.3. If we measured 4.1, maybe something went wrong. That's okay, right? We're just doing it with the ruler, okay? So accuracy is not a big deal. But now we know. Now we know exactly. We didn't even need to draw this triangle. The answer's there.